All right, welcome. This is a tutorial over unbalanced chemical equations. So we've already had the lesson. This is if you need additional help. All right, so I'm going to write a couple different equations on the board, and I'm going to solve them together. We're going to start off with an easy one. HgO is going to have a reaction, and it's going to be Hg plus O, oxygen. All right, so we have here on the left-hand side, we have our reactants right here. We're going to have a reaction actually happening and our product. So reactants, sorry, I don't know who that was. So we have our reactants and our products. So first thing I'm going to do is draw a little line underneath my arrow. Then write down all the unique elements down here. That Hg and O. Now I know it's not just H, then the G, so you have a capital, then lowercase. This is one element. Then O is our oxygen. I'm going to copy this and put it right here too. So Hg and O. Right, now let's just count our atoms. So I see right here, I don't have any number right here. So let's go ahead and pretend there's an imaginary 1. Now how many hydrogens do we have? We count our subscripts. 1. We don't have a coefficient, so that's also imaginary 1. So 1 times 1 is 1. Right, for oxygen, same thing. We don't have a number there, so imaginary 1. 1. Let's go to our product side. So we have Hg again. We don't have a number, so the imaginary 1 will do. Let's put it down. Same thing for oxygen. Don't have a number there, let's put 1 there also. This will also be a 1. So this one's pretty simple. Let's see here. Does 1 equal 1? It does. That one's good. Does 1 equal 1? It does. That's also good. So this one will be balanced. All right, let's try another one. All right, this one get a little messy here. This thing does not clean up well. Let's trash that away. Let's get a brand new one. Yeah, that looks good enough. Let's get rid of that. A little bit of magical Windex. There we go. All right, let's try one that's a little bit more complicated. Let's try some CH3. Apparently it's not dry enough. It's kind of running a little bit. So just, there we go. CH3 plus 2O2 reacts or combines. You have CO2 plus 2H2O, some good old water. All right, so the first thing I want to do is draw a line underneath my arrow. Then I want to start listing out my unique elements. So carbon is a unique element. Hydrogen, let's put it down here too. Then oxygen, okay. Now let's copy this and put it here. You want to copy exactly the same way. You don't want to come down here and put C, O, then H, and start having a mess. So copy this exactly the way it is and put it over here. So C, H, then O. Okay. So let's start counting our carbon atoms. Look up here. I don't have any number down there, no subscript. Let's put imaginary 1. Let's count. We have just one of those. Now we don't have a coefficient, so right now we're pretending it's 1. So 1 times 1 is 1. Hydrogen, okay, we have a 3 there. Do we have a coefficient? No, we don't, so that's good. We have oxygen. We have a 2 as a subscript. We have a coefficient of 2, so 2 multiplied by 2, right, which will equal 4. Now let's take it to the product side. So we have carbon, imaginary number 1. Oxygen. Oh no, I'm sorry, I'm going out of order now. Hydrogen. See, I almost messed it up. Go here, I have a 2. A coefficient of 2, so 2 multiplied by 2, which will equal 4. Now store oxygen. I have 2 right here, but I have another one over here. We're going to add these together. So these 2 plus what we got on this side, put a plus. But what do we have? We have a imaginary 1, that 1, and a coefficient, so we're going to multiply those. So 1 times 2, which is 2. So we're going to take this oxygen and add it to that one. So 2 plus 2, which will equal 4. All right, let's see. Do they match? We have 1 carbon, 1 carbon. That is following the law of conservation of mass. Next one, 3 and 4. Uh-oh, it is not. That's not good. Oxygen, we have 4 and 4. That is good. So this one is almost, but not quite. So this is not right. This would be unbalanced. It's supposed to be a B. All right, so this does not follow the law of conservation of mass. Law of conservation of mass says, which you start with, is what you have to end with. So we have 3 hydrogens here and 4 over here, so that does not work. That's no-no. All right, let's throw let's do 2 more. Stir this up a little bit. It's kind of cool when it does that. So another rag, spraying a little bit more. A little bit more. All right, and one more dried up just to make sure. Great. Let me make sure I marked off my little guidelines for the height. All right, and there. Okay, let's do another one. See, aluminum, which is Al, 2, and oxygen, 3. These are going to have a reaction. It's going to create Al plus O2. All right, the first step I want to do, and actually let's make this a bit more challenging. Let's put a 2 right here. Why not? Put a little line underneath my arrow, or my yield. Let's list out our unique elements of Al and O, so aluminum and oxygen. Let's copy these and put it right here. So Al and O. Let's count them. So aluminum has 2. The subscript is 2. We do not have a coefficient, so we don't need to multiply it. For oxygen, we have a 3, a cute little 3. Good. Let's move on to the right-hand side. For aluminum, we don't have a small number right here, so we're going to put an imaginary 1. We have 1 times 2, total 2. What about our oxygen now? We got 2. All right, let's put 2 down. Let's see, do they match? Aluminum, we have 2. Aluminum, we have 2. Aluminum is good. What about oxygen? We have a 3 and a 2. Not good. So this does not follow the law of conservation of mass. We have an unbalanced equation. Okay, let's try one last one. This one will be a little bit more difficult, probably the most difficult one. It's kind of dirty. All right. All right, let's make a long one. Let's make just too high. No. Ba Cl2. Add those to hydrogen to sulfate. So BaCl plus H2 is going to react or combine to create BaSO4 plus HCl, hydrochloride. Okay. So this is a bigger one. Ooh. How should we do this? Well, let's start off by drawing a line underneath our arrow, then listing out our unique elements. It should be H. I don't know why that looks weird. Okay. We have a BA. We have a CL. So it's not CI, it's CL, because they have a capital and a lowercase. We have a hydrogen, sulfur, and oxygen. That's a lot. Let's copy what we have here and put it right here. We have BA, CL, or hydrogen, sulfur, and oxygen. All right, well, let's get started. Do we have any coefficients here? We do not. All right, so let's start off with BA. We don't have a number, so put imaginary 1. So we have one of those. What about CL? We have a little subscript of 2. So we have 2 right there. No coefficient, so we're good. Hydrogen, we have 2 of those. Sulfur, see, we don't have a number there. Just put imaginary 1. Our oxygen is 4. Right, that's pretty simple. Let's go to the right-hand side, to our products. All right, so BA, again, we have imaginary 1. Our chlorine, which is imaginary 1. Our hydrogen, imaginary 1. Sulfur, imaginary 1 right there. And our oxygen is 4. Okay, so do these match? So BA1, BA1, that's good. Our chlorine, nope. Our hydrogen, get 2 and 1, no. Sulfur, 1 and 1, yes. Oxygen is 4 and 4. That's good. So this does follow the law of conservation of mass. Okay. I'm going to throw one more in there just for fun. And I'm not going to actually solve it. I'm just going to throw it up there because you may see this in a different way. It might not be counting atoms. It might be, does this equation follow the law of conservation of mass by giving you a mathematical situation? Sometimes they might throw like a weight down there. Not a weight, a mass. Because it is the law of conservation of mass. Right. It's not completely clean, but it's good enough. And I'm going to make an equation up here. This was not going to be accurate at all. I mean, by no means. But to say, use one I love using. We have H2 plus O2 reacts and creates H2O. Let's put a 2 up here and a 2 right here. Okay, so we can see we have 4 hydrogens here and 4 here. 2 oxygens and 2 oxygens because that coefficient. But what if sometimes, and this just means mathematically in there, they throw 4 grams plus something grams is going to react and create, I don't know, 10 grams. Would you be able to solve this one too? Knowing the law of conservation of mass is what you start with is what you end with. Could you do this? Okay, so what you start with is what you end with. Remember, this arrow, when doing math, you can treat this as an equal sign. So you might want to do 4 plus something equals 10. All right, I'm going to give you the answer because I'm sure you'll probably get that. That's just another way you may see that. All right, well, there you go. Hope you have a great day.